Download this code from codegive.com, link in the description below. Railsconf 2015, The World of Rails Security, a deep dive. This tutorial will explore the key concepts and techniques presented at Railsconf 2015 regarding Rails security, focusing on common vulnerabilities and practical mitigation strategies. We'll cover SQL injection, cross-site scripting, XSS, cross-site request forgery, csrf, mass assignment, and authentication/authorization best practices. While Rails has evolved significantly since 2015, the foundational principles remain crucial for building secure Rails applications. Why Rails security matters. Rails, while a powerful and productive framework, is not inherently secure. Like any web framework, it's susceptible to vulnerabilities if not implemented correctly. Neglecting security can lead to data breaches, sensitive user data, passwords, financial information, personal details, could be exposed or stolen. Application defacement, attackers could alter the application's content, damaging your brand and reputation. Denial of service, exploiting vulnerabilities could overwhelm your server, making it unavailable to legitimate users. Account takeovers, attackers could gain unauthorized access to user accounts, impersonating them and performing actions on their behalf. Core Rails security principles. Before diving into specific vulnerabilities, it's essential to understand the core principles of secure Rails development. 1. Least privilege, grant users and applications only the minimum necessary permissions. 2. Defense in-depth, implement multiple layers of security to mitigate the impact of a single vulnerability. 3. Input validation, sanitize and validate all user input to prevent malicious data from entering your application. 4. Output encoding, encode output to prevent malicious code from being executed by the user's browser. 5. Regular updates, keep your Rails framework and dependencies up to date with the latest security patches. 6. Security audits, regularly review your code for potential vulnerabilities. SQL injection. The problem SQL injection occurs when an attacker inserts malicious SQL code into a database query through user input. If the application doesn't properly sanitize this input, the attacker can potentially read, modify, or delete data in the database. Example: vulnerable code. In this example, params query is directly interpolated into the SQL query. If an attacker provides a malicious input like, the resulting SQL query becomes. This could potentially drop the entire user's table. The solution: using parameterized queries. Rails provides built-in mechanisms to prevent SQL injection using parameterized queries. By using the placeholder, Rails automatically escapes and sanitizes the params query value, preventing SQL injection. Key takeaways: never concatenate user input directly into SQL queries. Always use parameterized queries, example placeholders, named parameters, for dynamic values. Use active records methods, example where, find_by, update, which automatically use parameterized queries. Avoid using raw SQL queries unless absolutely necessary, and even then, meticulously sanitize input. 2. Cross-site scripting, XSS. The problem XSS occurs when an attacker injects malicious JavaScript code into a website, which is then executed by other users' browsers. This can be used to steal cookies, redirect users to phishing sites, or deface the website. Types of XSS: stored XSS, Persistent XSS. The malicious script is stored in the database, example a comment or a profile field, and displayed to other users when they view the content. Asterisk reflected XSS, non-persistent XSS. The malicious script is injected through a URL parameter or form submission and immediately reflected back to the user in the response. Asterisk DOM-based XSS. Asterisk the malicious script manipulates the DOM, document object model, of the website, typically by exploiting JavaScript code that handles user input. Example, vulnerable code, stored XSS. If a user submits a comment with the following body, the browser will execute the JavaScript code, displaying an alert box. A more malicious attacker could steal cookies and send them to their server. The solution, output encoding. Rails provides built-in mechanisms to escape HTML entities in output. 1. Using HTML_escape, or the shorthand H. This will escape the end characters, preventing the browser from interpreting the code as HTML. The output would be 2. Using sanitize ***. The sanitize helper allows you to specify which HTML tags and attributes are allowed. This is useful when you want to allow some HTML formatting but prevent malicious code. This will remove any HTML tags that are not explicitly allowed. 3. Using content_tag***. Instead of directly interpolating user input, use content_tag to create HTML elements. This can help prevent XSS by escaping attributes correctly. 4. erbutil.html_escape and erbutil.json_escape directly. Key takeaways ***. Always escape user-generated content before displaying it in the browser. Use HTML_escape, H, or sanitize helpers to encode output. Understand the different types of XSS and how to prevent them. Consider using a content security policy, CSP, to further restrict the types of content that the browser can load and execute. CSP is a powerful HTTP header that allows you to control the sources of scripts, styles, images, and other resources that the browser is allowed to load. 3. Cross-site request forgery, CSRF. The problem CSRF occurs when an attacker tricks a user into performing an unwanted action on a website they are logged into. The attacker exploits the user's authenticated session to send malicious requests on their behalf. Example ***. Imagine a user is logged into their bank account. An attacker could send them an email with a link to an image on a malicious website. That malicious website contains a hidden form that submits a request to the bank to transfer money to the attacker's account. Because the user is logged in, the bank will process the request, unknowingly transferring money to the attacker. Rails solution, CSRF protection. Rails automatically includes CSRF protection in your application. It works by generating a unique token for each user session and including it in forms and AJAX requests. When a request is submitted, Rails verifies that the token matches the session token. If they don't match, the request is rejected. How it works ***. 1. Protect _from forgery with exception ***. This line is typically included in your application controller. It enables CSRF protection and raises an exception if the token is missing or invalid. The exception strategy is recommended. 2. CSRF token in forms ***. Rails automatically inserts a hidden field containing the CSRF token into all forms generated using Rails form helpers, example form_with, form_tag. 3% equals CSRF_meta_tags %**. This helper generates meta tags containing the CSRF token, which can be used by JavaScript to include the token in AJAX requests. Handling AJAX requests asterisk. For AJAX requests, you need to include the csrf token in the request headers. Key takeaways asterisk. Asterisk ensure protect _from _forgery with exception is enabled in your application controller. Asterisk use Rails form helpers to automatically include the csrf token in forms. Asterisk include the csrf token in the headers of AJAX requests. Asterisk consider using same-site cookies for additional protection against csrf, especially in modern browsers. 4. Mass assignment. The problem asterisk. Mass assignment occurs when you allow users to update multiple attributes of a model at once, potentially including attributes they shouldn't be allowed to modify. This can lead to unauthorized data modification. Example, vulnerable code. If the user model has an is_admin attribute, an attacker could potentially set this attribute to true by including it in the params user hash. The solution: strong parameters. Rails provides strong parameters to protect against mass assignment vulnerabilities. Strong parameters require you to explicitly permit which attributes can be updated through mass assignment. In this example, only the name, email, password, and password_confirmation attributes are permitted for mass assignment. If the params user hash contains any other attributes, they will be ignored. Key takeaways asterisk. Asterisk always use strong parameters to protect against mass assignment vulnerabilities. Asterisk explicitly permit only the attributes that users are allowed to update. Asterisk avoid using @accessible or @protected, deprecated in newer Rails versions. V. Authentication and authorization. Authentication asterisk verifying the identity of a user. Authorization asterisk determining what actions a user is allowed to perform. Best practices asterisk. 1. Use a secure password hashing algorithm asterisk. Don't store passwords in plain text. Use a secure hashing algorithm like BCRYPT, or Argon2, to hash passwords before storing them in the database. Rails has _secure_ password macro automatically handles password hashing. 2. Implement proper password reset mechanisms asterisk. Implement a secure password reset process that requires users to verify their email address before changing their password. Generate unique, time-sensitive tokens for password reset links. 3. Use a robust authentication library asterisk. Consider using a well-established authentication library like Devise or Clearance. These libraries provide pre-built authentication logic and security features. 4. Implement authorization rules asterisk. Define clear authorization rules to determine what actions users are allowed to perform based on their roles and permissions. Asterisk can asterisk. A popular authorization gem that allows you to define abilities in a central location and check them throughout your application. Asterisk Pundit asterisk. Another popular authorization gem that uses simple Ruby classes to define policies for each model. 5. Two-factor authentication. 2FA implement 2FA to provide an extra layer of security. 2FA requires users to provide a second factor of authentication, example a code from their phone, in addition to their password. 6. Session management asterisk. Asterisk secure cookies asterisk. Ensure that session cookies are marked as secure, only transmitted over HTTPS, and HTTP only, not accessible to JavaScript. Rails configures this by default. Asterisk session expiration asterisk. Set appropriate session expiration times to limit the window of opportunity for session hijacking. Asterisk revoking sessions asterisk. Provide users with a mechanism to explicitly log out and invalidate their sessions. Example, using can. Key takeaways asterisk. Asterisk use a secure password hashing algorithm. Implement proper password reset mechanisms. Consider using an authentication library like device or clearance. Define clear authorization rules using a gem like can or pundit. Implement two-factor authentication for added security. Manage sessions securely, secure cookies, session expiration, session revocation. 6. Other important security considerations. Regularly update gems. Use bundle update to keep your gems up to date with the latest security patches. Be aware of gem vulnerabilities reported by tools like Bundler Audit. Secure file uploads. Validate file uploads to prevent malicious files, example PHP scripts, from being uploaded and executed on your server. Restrict file types, file sizes, and file names. Use a gem like Carrier Wave or Paperclip to handle file uploads securely. Denial of service, DOS, attacks. Implement rate limiting to prevent attackers from overwhelming your server with requests. Use rack attack or similar middleware to block malicious traffic. Information disclosure. Avoid exposing sensitive information in error messages or debug logs. Configure your application to display generic error messages in production. HTTPS. Always use HTTPS to encrypt communication between the client and the server. Content security policy, CSP. Implement CSP to restrict the sources of content that the browser can load and execute. Security headers. Use security headers, example X-frame options, XXSS protection, strict transport security, to further enhance the security of your application. Consider using a gem like secure_headers to manage security headers. Auditing. Regularly audit your code and logs for potential security vulnerabilities. Use security scanning tools like Brakeman to automatically identify potential issues. Dependency scanning. Regularly scan your dependencies for known vulnerabilities using tools like Bundler Audit or SNYK. Environment variables. Store sensitive information, example API keys, database passwords, in environment variables rather than hard-coding them in your application. Use a gem like Dotenv to manage environment variables in development. Avoid using eval or instance_eval on user inputs. These are prime vectors for code injection. Secrets management. Store your secrets in a secrets management tool such as AWS Secrets Manager, HashiCorp Vault, or similar tool. Don't commit your secrets to source control. 7. Security tools and resources. Brakeman. A static analysis tool that scans Rails code for security vulnerabilities. Bundler Audit. A tool that checks for vulnerable gems in your application. SNYK. A security platform that helps you find and fix vulnerabilities in your code and dependencies. OWASP, Open Web Application Security Project, a nonprofit organization that provides resources and guidance on web application security. Rails Security Guide. The official Rails Security Guide. Ruby SEC. A community dedicated to Ruby security. Conclusion. Security is an ongoing process, not a one-time task. By understanding common vulnerabilities and implementing the mitigation strategies outlined in this tutorial, you can significantly improve the security of your Rails applications. Remember to stay informed about the latest security threats and best practices, and to regularly review your code for potential vulnerabilities. This information provided builds upon the key security concerns highlighted in Railsconf 2015 and remains relevant for building secure Rails applications today. Keep learning, keep patching, and keep your users safe.